Hey there, so today I'm going to do the problem number 49 which is given to us by professor. So the question is there is a uniformly charged ring with a certain charge on it and we have to find the electric field at at point 0.8 meter from the center of the ring and the radius of the ring is r. Alright, so I'm trying to give a general solution for this. Okay, so I'm supposing that there is a p point which is at a distance x from the center of the ring and the radius of the ring is r, and I have to find the electric field at this point. So if we see this problem, so if we see a small element, a very small element on this ring, then the electric field because of this element will be in this direction. Alright, in this direction, and as we change the element of the ring, the direction of electric field will change, and as the electric field is a vector quantity, therefore its direction is very important. It is not scalar, so we can't simply add the magnitude, therefore we have to take care of the direction. Okay, so what we'll do, okay, so let's be quick. We will use Coulomb's law for it, of course. Coulomb's law, which gives the force between two charged particles which have a charge q1 and q2 on them and which are separated by the distance r. So the force is given by k q1 q2 by r square, where r is the distance between the center of mass of the two charged particles. Okay, alright. An electric field is defined as the force which will be exerted on a unit positive charge if it is kept at a distance x from a charged particle. Okay. So if electric field is force on a unit positive charge, so the magnitude of the charge will be 1, so the force will be kq by r square. But the problem here is that the direction of electric field because of each individual element is different. So what we have to do is that we have to break this ring into small elements. Alright, so we are supposing that this ring is uniformly charged and that charge is lambda. Lambda is the charge per unit length. Okay, so we will take a dx element over here. Okay, so the electric field because of this dx element will be here in this direction. Okay, so let's try to imagine this question. The electric field, if because of all the dx elements, will be in different direction, and if we try to imagine it in 3D, a funnel will be created. A funnel will be, a type of this funnel will be created here. So if we try to draw this, a type of funnel will be created. Okay, and as the ring is uniformly charged, therefore the magnitude of electric field will be same. Therefore, if we take this, what we can see, let's draw this first, of course. Okay, so if this is theta, the angle, so this will be theta. Okay, so the horizontal component of electric field will add up and the vertical component of electric field will cancel out each other. Because the ring is uniformly charged, therefore the magnitude of electric field will be same, therefore the vertical components will cancel out each other. Okay, so let's be fast. So we will apply the Coulomb's law for this. K, the charge on this dx element will be lambda times dx, k lambda dx, k q1 q2 will be 1 because we are finding the electric field, k q1 q2 by r square. R is the distance of the point where we are finding the electric field from the charged particle which is exerting the electric field, because of which we are finding the electric field. So the dx will be, so we will use Pythagoras theorem, x square plus r square over here, and r square, so the under root will be cancelled out. So this is okay, so the variable over here is dx. Okay, alright, so this is the electric field on this point, but we want the horizontal component of this electric field. So this is the electric field, total electric field. We want the horizontal component, so we want E cos theta. So the E cos theta will be k lambda dx upon x square plus r square. Cos theta is x upon under root x square plus r square upon under root x square plus r square, so it will be the power 3 by 2. So we have to add the electric field because of all the components, we will integrate it from, okay, so from 0 to, the variable is dx, and dx, the limit will go from 0 to 2 pi, okay, if we add up all the dx elements, we will get the circumference of the ring. So basically, if we want to integrate that, then we can, but we can directly write it as 2 pi r. so they are constant, they will go out of integration. It will be over here, it will be 2 pi r upon x square plus r square to the power 3 by 2. Okay, is the constant. Lambda is charge per unit length. Total charge is q. We are supposing that we are provided q charge on the ring, and a charge per unit length, so total length is r k 2 pi r upon x square plus r square to the power 3 by 2. So here, wait a second. Yeah, we forgot that x. So it will be here, it will be here. So it will be kqx upon x square plus r square to the power 3 by 2. This is the electric field at any general point which is at a distance x from the center. So if we want the electric field at the center, then the x becomes 0. So x, if we put x 0 over here, so the E will be, electric field will be 0. And yeah, that's pretty much it. And Dr. Volchan has provided us the numerical values. Alright, so we can put the numerical values and we can find electric field at center will be 0. We can also imagine it. If a point is, if there is a ring and if you are sitting in this point at the center, then the electric field for because of this dx element will be here, and just opposite to dx element, electric field because of this will be here, so they will cancel out each other. Similarly, they will cancel out, and the net electric field will be 0 over here. And for at what's the point? It is okay. So r is 0.5, r is 0.5, distance is 0.8, x is 0.8. So we can put in the values and we will find the answer. What we got, kqx, I think so. Kqx, k is 9 to the power n, q is 2 microcoulomb, kqx, x is 0.8 upon x square 0.64 plus r square 0.25 to the power 3 by 2, and we can find the answer. Okay, so I am from India, in the state of Gujarat, in the city of Surat. My name is Prakhar, and actually I am a GIS parent. So recently I saw that the video that many students just they directly gave the answer. So the professor pointed out that we are cheating. So that's why I decided to make this video, short video, a small, just a small proof that we just don't mug up the formulas and we know how to derive them. So yeah, that's pretty much it. Thank you.